Hello everyone, welcome once again to our channel, Making Life Easier, and on our series on basic mechanics. Kindly subscribe, share, comment, and hit the notification bell as well. Today we are looking at resultant of forces in 3D. Resultant of forces in 3D. So quickly, let's look at our example. Two forces act on a boat at point V, as shown in the diagram. Determine the magnitude and the direction of the resultant force. So we have two forces, F1 and F2. And looking at the axis, we have three axes. We have the X, the Y, and the Z. And we are asked to determine the resultant of the force. The resultant of the force will have both magnitude and direction. Let's look at how to solve that quickly. Good. So in our previous examples, we look at how to be able to find the component of a force, or how to convert forces from scalar form to vector form. We have to look at that. So we need to convert these forces from the scalar form to the vector form or to the component form before we can find the resultant. Yes. So since we have three axes, the X, Y, and the Z, we said that our object is three-dimensional. But don't forget that we have stated that anytime it is three-dimensional, you want to get a component. F is equal to F, which is a vector form, or the component form is equal to F in the scalar form times lambda. S in the scalar form times lambda. That is our formula. Good. So if that is the case, we have said that we need to first determine our lambda, and we said that lambda is either equal to cos theta xi plus cos theta yg plus cos theta zk, or our lambda can be equal to d over dx, dx over d I plus dyg over d plus dyz dkz over d. But in this case, you have been given, for f is equal to 700, you have been given in angles, and this one you have been given in distances. But look at the way the distances were given. They were given in form of the y-axis, the x-axis, and the hypotenuse. So we will look at that. So quickly, let's look at how to solve this problem. So the first one is to put all the forces into the component form. So let's look at the first one, which is F1, force F1. So F1 in the vector form will be equal to F1 in the scalar lambda. So let's determine lambda for F1. So for lambda, we have been given the angles there. We said that our lambda will be equal to cos theta xi plus cos theta yj plus cos theta zk. So we can see that here we have the cos theta xi is the angle the force makes with the x-axis. Cos theta yj is the angle the force makes with the y-axis. So this is the angle the force makes with the y-axis. This is the angle the force makes with the x-axis, and this is the angle the force makes with the z-axis. So from here we can say that cos theta xi is equal to the angle the force makes with the x is equal to 120 degrees. Theta yj, the angle the force makes with the y, is equal to 55 degrees. And then our theta zk, which is the angle the force makes with the z-axis, is equal to 60 degrees. So from here, our lambda will be equal to cos 120i plus cos 55 J plus cos 60K. And from there, our lambda will be equal to negative 0.574I plus 0.574J plus 0.5K. So you have been able to determine our lambda. Once you have been able to determine our lambda, then the rest is to multiply our force by the lambda. So our force in the vector form will be equal to, we know that the magnitude, the scalar, is given at 700. So it's equal to 700 into bracket negative 0.574I plus 0.574J plus 0.5K. And from there, we can see that our F1, our force F1 in the vector form will be equal to 401.8 I, which is the x component, plus 401.8 J in the y-axis, and then our force in the z-axis will be 350 K. So we have been able to resolve F1 into components. Now let's also resolve F2 into components. How do we resolve F2 into components? So let's take it that the angle this F2 makes with the x-axis is theta x or phi x, and the angle it makes with the y-axis is phi y. So if that is the case, we have been given that on this line, we have been given that the vertical component is 8, the horizontal component is 6, and the hypotenuse is 10. So from this diagram, you can see the way the diagram is drawn shows us that the force can only be resolved into the y component and in the x component from the diagram. As you can see, it tells us that our force can, with the help of this diagram, it is telling us that our force can only be resolved. Look at this diagram. It is telling us that our force can only be resolved in the y-axis and in the x-axis. So from there, we can resolve our force by using these angles, which we are saying that we have theta x and we have phi x and then we have phi y. So we can say that our phi x and then phi y are representing the angle this force makes with the x-axis and the angle it makes with the y-axis. So if that is the case, then if we want to get this side, it is adjacent to our angle here, which is phi x. If we want to get this side, it is adjacent to that angle. So we can say that cos phi s will be equal to the adjacent over the hypotenuse, which we are given as 10. So the adjacent is 6. It means that this, so it means that we are going to use our 6 here, which is the adjacent from this diagram, and our hypotenuse is 10. So cos phi s will be equal to 6 over 10. And then we can also get cos phi y. So cos phi y will be this side, it will be this side. The angle the force makes with the y-axis. So cos phi I, if you want to get this side, then this side is now also adjacent to the angle phi. This side is also adjacent. Is also adjacent to this angle phi y. This side is adjacent to the angle phi y. So if it's adjacent, then we can say that now from this side will be adjacent. This side will be adjacent to the angle. So the side here is adjacent to the angle. So it means that in this case, you are going to use our cos phi y will be equal to this side, which is 8 over the hypotenuse, which will give us 8 over 10. 8 over 10. So you have gotten our cos phi s and then we have also gotten our cos phi y. But look at this direction. You can see that for phi x, our adjacent or our distance will be moving this direction, which is in the same direction with our unit vector for x here. It's in the same direction. Don't forget that you have already stated that our unit vector should move this direction. So this will be our y, this will be our x, and this will be our a. So this x will be represented with I, y will be represented with j. So if it's moving in the same direction with our I, it's going to be positive. But if it's in the opposite direction, it's going to be negative. If it's moving this direction, it's positive. But if you are going in the opposite direction, then it's negative. So this will be, this side will be negative, this side will be negative. Y also, if you are coming down, it's negative. So you can see that here on this distance, you can see that we are moving in the same direction with our x, which is the I, the unit vector for x, which is the I. So it means that this side will be positive. But now on our y, look, you'll be coming down. If you want to get to this point of the force, you'll be coming down. You'll be coming down like that. And because you'll be coming down, it is against the direction of our unit vector j. It means that our cos phi y is going to be negative 8/10. Good. So once you have been able to establish those things, then we can easily get our lambda for F2. So our lambda for F2 will be equal to cos. We know that the F2 is making, we only have the x component and the y component. So we are going to get cos theta xi plus cos theta yj. And then we have gotten all those from our previous example. So we are going to get 6/10 minus our cos phi y, which is 8/10. We have gotten our lambda. And then from there, we can get our f. So our f2 in the vector form will be equal to f lambda. And f2 in the vector form is going to be f, which is now 350. Our f2 is 350 into bracket 6/10 minus 8/10. And from there, so this will be I, and this will be j. So this I, this is j. I, this is j. And from there, our f2 will be equal to, our f2 will be equal to 210I minus 280j. So we have gotten our f1 in the vector form, we have gotten our f2 in the vector form. So now we can get our f, our resultant of the force. Don't forget that in the question we're asked to find the resultant. So our resultant of all the forces will be equal to vector force vector F1 plus force vector F2. So now what we need to do is to add them together. So quickly, let's look at how to do that one, how to add all of them together, So don't forget that we have already gotten our vector F1 and our vector F2. So we can find the resultant force in the vector form. So in the vector form, now we can write it as, we can say that our F resultant will be equal to our F1. Our F1, we had negative 40. Let me change my marker. It seems it is not coming clearly as I want it. So we are going to get negative 401.8I plus 401.8J plus 350K. So this was our force for F1. So this plus our force in the F2, which we have it as 210I minus 280J. So from here, what we do is that you put all the components of the S together and also put all the components of the y and all the components of g together. So I will have this and that. So when we add the two, we are going to get our f will be equal to all the I components. So the I component, you have 401.8 plus negative plus 210. This will be our I components plus our y components, which is 401.8 minus 280J. And then we put our z component also. So our z component will now be, the z component you only have one. So we are going to get 350K. And from there we put them together. So our force resultant in the vector form will be equal to negative 191.8I plus 121.8J, 121.8J plus 350K. And once you have been able to do this, then now we can find the magnitude of our force, because don't forget that the question asks us to find the magnitude of the force and the direction of the force. So the magnitude of our force resultant will be equal to square root of whatever is here square, which is 191.8 squared plus 121.8 squared plus 350 squared. And from here we can get our F magnitude to be equal to 417.3 Newton. So we are done with the A part of the question. This is the A part of the question, which is the magnitude of the resultant force. So now let's go to the B part of the question, and then we try to find the angles, the angle of the resultant force, the angle of the resultant force. Don't forget that here, because the object is three-dimensional, the angle of the resultant force is going to make an angle with the x, an angle with the y, and an angle with the z. So it means that we are going to get three different angles. But we know that cos theta xi is equal to the force in the x-axis, which is this one. So fx over f, the force in the x-axis over the magnitude of the force which we have here. So from here we can state that our cos theta xi will be equal to negative 191.8 over the magnitude of our force, which is 417.3 newtons. And from here we can say that theta xi will be equal to cos inverse of whatever is there, which is negative 191.8 over 417.3 newtons. And from there, our theta xi will be equal to 117.4 degrees. Then, so this is the angle the force makes with the x-axis. We can also get the angle the force makes with the y-axis, which we are going to get cos theta yj will be equal to the force in the y-axis over the magnitude, which we are going to get 121.8 over 417.3. And from here, if you find the cos inverse of whatever is there, this will be equal to the force in the y-axis over our f. So when you get the cos inverse of all that is here, our theta yj will be equal to 73 degrees. And then we can get the angle the force is making with our z-axis, and that will be equal to f of z over f, which is our force in the z component over the magnitude of our force. So in this case, we are going to get this to be equal to the value of the force in the z component, which is 350, over our resultant force, which is 417.3. And from here, we can say that when we get the cos inverse of whatever is here, our theta zk will be equal to 33 degrees. So it means that the magnitude of our force is 417.3, and this resultant is making an angle of 117 with the x-axis, an angle of 73 degrees with the y-axis, and an angle of 33 degrees with the z-axis. So we have been able to find the magnitude and the direction of our resultant force. This is easy. If you have any comment, any suggestion, or anything you didn't understand, you can let us know at the comment section. You can make us know at the comment section. We believe this is pretty simple and you can easily follow through and understand. But if there is anything, you can make us know at the comment section. Once again, we want to thank you for your time in watching our videos, but we humbly plead that you kindly subscribe to our channel, you share, you like, and then you hit the notification bell. Bye-bye. See you in our next video.